Well, good afternoon, good evening, and good morning, everybody. Welcome to the Machines Talk and Data Walks presentation, your AI guide to the AI-powered manufacturing odyssey, presented by Softura this afternoon. And this will be recorded. We're going to have a question and answer session afterwards. And I'll do a brief introduction to myself. Frank Brasky. I'm the Chief Evangelist for Artificial Intelligence, Internet of Things, and Robotic Process Automation at Softura. And it's my distinct honor to present to you Mohan Jayaraman. He's our Vice President of Emerging Technologies, including AI and IoT and manufacturing. Here's our contact information. And because we are doing this live, I get the opportunity to brag a little bit on Mohan, since he would probably never do this himself. This is what he had wanted to share with you. He's got over 25 years of experience in helping architect and build solutions for digital enterprises, including IoT and analytics and machine learning and big data at Softura. He's also been involved with various projects from General Motors at OnStar and Ford and Komatsu, Cooper Standard and Cummins. And he's passionate about the Internet of Things and driving value for enterprise with data-driven insights. However, I like to think of it as he's been doing AI and machine learning and the Internet of Things and Industry 4.0 and 5.0 before people knew that was a thing. He was one of the real principal architects and chief drivers, making all the connected vehicle services that you know and love from GM possible. From his early days, he helped launch the first 4G LTE connected vehicle service, as well as worked on smart grids and renewable energy systems management and machine learning for the Department of Energy. He also helped implement a fleet EV fleet management system for Google, and has done significant work at Cummins, Ford, and GM, as well as Komatsu, and a variety of other companies in the industry. And it's not very often I get to say he's also got one more patent than I do in both of these spaces. So it's my distinct pleasure to introduce you to Mohan, as he'll be the main presenter today. I'll be helping facilitate. We're going to go through navigating the IoT manufacturing maze. Mohan will give us kind of his recipes for human-machine interactions. We'll talk about the future factory, the types of obstacles and barriers that you need to overcome. He'll go through 2 case studies, and then we'll do some Q&A. So if you'll hold your questions, you can also actually bring your questions into the Teams environment, as well as type in comments there if you'd like to see that. And without further ado, I'll let Mohan kick it off.
Thank you, Frank. Thanks for the introduction, long introduction, but it's mainly going to be some knowledge sharing, and like to interact with your questions and what you are seeing on your side of the space. So I'll be glad to take questions towards the end. So as you can see, the topic, it's an odyssey, it's a journey. So it's not an overnight thing to take your existing factory floor and then convert into a smart factory or a factory 2.0 or a future factory, whatever people call. And it is indeed a maze. I say that because you need to have a strategy, you need to have a navigation tool in order for you to attack and get to your destiny of where you need to get to. There are various concerns in this maze. I know there are some people who are concerned about the production efficiency part. Some are responsible for the occupational health and safety hazards and creating a safe environment. There are some folk are working on the back end with respect to the supply chain and getting the forecasting right and the quality and so. But all of these concerns are so intertwined that if you try to only tackle one or two of this without having a holistic picture in your journey, you're not going to be successful, or you're going to have only a partial success, because each one of them have its own unique characteristics, unique challenges and the causes, but they are so intertwined. We'll see it in the presentation shortly. We can go to the next one, Frank.
Okay, actually, I realized I forgot to launch our first poll. This is the first time we're doing this, so apologies.
Definitely, go for it.
you should have a poll up on your screen with the first question being, what is your personal experience with IoT? And then you can make a selection there and then choose go to the next one. And you can enter those in and we'll kind of get a sense of where everybody's at in this.
That's interesting to see some numbers coming in.
Yeah. Okay.
Very good.
All right. Thank you so much. And with that, we'll move on.
That's a good segue to see that the concerns are widespread and different people have different areas of focus. But the top of the list, it's not surprising to me, is the production efficiency. So we'll jump right into it, the production efficiency part. So we can go into the production efficiency, yep. Frank. When it comes to production efficiency, the first and foremost thing we all think about is the uptime of the machines. Machines are bound to fail, they do fail, and we all know that, right? And it's extremely critical for us to keep the machines up and running all the time. But that's not the only factor which decides the efficiency, which is usually, as you all know, measured in OEE terms. It's a function and factor of your availability, performance, and quality. So you got to keep your machines up and running. You got to keep them running at the highest performance that is possible. If your throughput and your rotation per minute or whatever your line speed is, you want to operate at the highest possible way. And you also want to spend time and energy not producing scrap. You want to be producing the goods that you can ship. So there are different things that can go wrong with respect to this. It's a machine problem. It could be a human factor problem. It could be a simple process issue where somebody is actually walking up a 25-meter line, end of the line, go take a printout, bring the label and put it in here, right? It could be a simple process tweak which you could do to improve the efficiency. Or it could be a production planning issue where you have a material shortage or the time it takes, which some of the production smart scheduling can solve it. So it's a variety of things. It could mean different things to different people, but it's a combination of availability of the uptime of the line, the performance of the line, and the quality. All three have to be taken into consideration in conjunction. The effect of having a poor efficiency here or lower OEE is not only an immediate problem with your throughput, but also the overtime that you are going to be, you have to get extra contractors, the labor involved in it, the lost opportunity and revenue, the penalty of not meeting your timeline, and a variety of things, right? So it's extremely critical and not surprising. 34% of this little survey we did, you're focused on production efficiency, and it's a very well-known problem. So we'll get into the details of how we solve it and how AI and IoT can solve this problem. Go to the next one, the quality concern, right? Quality, the cost of poor quality is at a staggering number of 20% in manufacturing. Literally, it means 1 in 5 days in your 5-day work shift, you're producing scrap. I know it sounds weird, but it's not just a scrap, right? It's the rework that is involved, the effort, the labor that's involved in the warranty claims, the returns that comes with it. You've lost credibility, you've lost certain sales opportunity because of your poor quality and whatnot, the compliances, the penalties that go with it, and a bunch of things. So again, the causes could be multitude. It could be all the way in the top of the chain with your design flaw or engineering flaw to probably a supplier not meeting on time and they're giving a poor quality raw material, or the raw material was not kept in a warehouse at a certain temperature and certain condition which you are supposed to in order for you to get the best yield. So it could be a variety of things, or it could be a process issue where the inspection, quality inspection is visual based, right? You can only do so much. I mean, I've seen in person, I visited plants, I've seen the operators, they work at a very, very, very high paced environment. They are always on the clock. I mean, it's impossible for you to do a 100% accurate job in the visual inspection. So some of the technology can come to rescue in certain cases, and sometimes it's a human error. make a mistake, you don't set a process parameter, you have to go up the line, change the parameter, stop the line, take all the parts which was producing scrap, weigh the scrap, record it in a piece of paper or a whiteboard, and then go back and resume it. So as much as we would think it's getting more and more digital, there are many plans. They are still operating with the whiteboards and the Excel sheets or sometimes a paper, and then every changeover, it gets recorded into Excel, and then the Excel gets into a master Excel, then it goes to a network drive Excel and whatnot, right? So the cost of poor quality is measured in two factors. One is the internal cost, and once it hits the customer, that's even more cumbersome, and even more it costs you because of all the other overhead involved in it. But this is one of the topmost concern. Most of the our customers, when I talk to, it hurts them, and it hurts really bad, and it's important. Technology again can come to rescue to this. We can move to the next one, Frank.
Okay.
Supply chain, age old problem, and it's not, this number shouldn't be surprising to any of you. It is one of the most affected. The supply disruption, and manufacturing is the one which is most hit all the time. There are so many factors which are beyond our control. Let's take COVID, right? I mean, the fluctuations, the supply disruptions, the logistics, things which are beyond our control. But there are many times you could forecast. The lack of forecasting or poor forecasting, or not having a mechanism to manage your inventory well, it hurts. And the challenges, these are so intertwined, because you're having suddenly a new order, you're trying to work towards the demand fluctuation, you bring in overtime, you add a new shift, your process is not solid, you don't have a technology foundation, so you end up producing poor quality. Because of poor quality, you're trying to catch up, and then that's affecting your efficiency. People are overworked. That's why I said it's so intertwined that you have to look at holistically when you're trying to do. Some of our customers have asked, can we just solve this problem in IoT? Yes, you can. Right? It is a journey. You have to do a focused area, but you got to have the big picture to know what you're trying to solve, what are the different areas, and then tackle in a way. There are certain things you have to tackle it with some certain tactics, but you have to have a solid strategy which is holistic in nature, and not with a small prism trying to solve one use case, and then I declare I've got a smart factory. We can go to the next one now, Frank. Most of it, what we are seeing, it shouldn't be a surprise to you. You all know this, but we're just setting the stage to really get into the real meat of our presentation. The sad part is 20% of the workplace fatalities are in the manufacturing space. It's not just a noise level thing, it's a chemical exposure, and we all want to keep an environment where it is safe for employees to work and the workforce to work. This is a problem where you have certain technology to rescue. There are different companies, they are already putting robots to use. There are techniques where you can detect whether the employees are wearing the safety vest. You can do the indoor geofencing. You can work on a better forecasting plan to reduce your fatigue and stress. There are several technological solutions which can get you a more safer workplace environment. A lot of investment has gone in, a lot of technology is there today, which was not possible a while back. Can go to the next one.
Yep.
It's actually surprising, right? We are at a point in time now. There are more jobs created. There is more to be done with less. So we have a technology today which is allowing you to accomplish more with less. Less time. You have more efficiency.
I don't know if that's my internet connection, but I lost you, Mohan.
Then if you are,
Yeah. Looks like we lost Mohan there for a second. We'll see if he can come back.
all right, sorry about that. I don't know
No
what
problem.
happened. My screen froze. So we have some technology issues as much as we talk about, technological advancement. But the point I was trying to say is, you want to accomplish more with less. So that goes all the way back to workforce training and how do you ensure that you innovate. If we don't innovate, we are stagnant. And we have seen the industries which have been behind the scenes, and if you are not catching up to the current trend, you're outdated, somebody is going to replace you. So some of the standard KPIs that you see here, they can be tackled, which is a holistic solution, again, by investing in the technology and being a technological leader. Every manufacturing company has a niche space where they want to focus on the technology and also want to have a technological component. Instead of you being a manufacturer of packaging material, how do you apply technology and you have a technology component of your thing in a go to market. So that's a good segue into the innovation and integration. So it's an interesting thing. So the conversation about the IT and OT intersection, it's a very common thing when we go and walk up, talk to the different stakeholders, right? Where does this really end? Where does the other one start? Such a blurry line. You have to have a strategy and a buy-in from all the stakeholders so that we look at it in a strategic way. Otherwise, a plant starts making decisions. If a plant has a budget, if that plant is quote unquote consider a gold plant or a diamond plant, they have budget, they go to the Best Buy, they go get some hard drive, they put some uh, a maverick attempt at some of the software solution, they run everything within the plant. That knowledge does not go to the outside world. They have their own master data, they have their own data strategy. It is a very very common sight. Our customers, when we walked up, it is so fragmented. It is very critical for an enterprise for you to take a step back and see, how can I take the learnings of one plant and then cascade to the other plant? How can I have a strategy which is global in nature? North America does it certain way, Europe does it different way, and Asia Pacific does it different way. Very common sight. Again, the key thing here is integration. You have to integrate systems. Everybody wants to solve the problem or they want to reinvent the wheel because you think you could do differently, but it's important for you to take a step back and integrate and break the silos, especially if you're trying to solve some of the problems like what we talked about. You have to have a global data strategy. Only with the global data strategy you can get the synergy and you can get the insights which can be applied back to the factory floor, because this is actually a closed loop. The data that you're collecting, you're running your insights, it has to flow back to the plant floor. So it is impossible for you to just do something in silo because you're missing out the whole thing. The other aspect of this innovation integration here is the machineries are often outdated. They come through acquisition. You would acquire certain lines and plants, and some of the plants are working fine. You do not have the capital budget to upgrade it, but it is extremely important for you to invest in some of these, because by investing in some of these technology and the machinery upgrade, you're not only enabling some of the new use cases, but you're also improving your immediate productivity. So but again, there is a blurry line, there is a science to it, there is a math to it, where you have to sit and then go through your ROI so that you can make the right decisions. Otherwise, nobody has a credit card with no limit, right? Everybody has got a budget, you got to operate within the budget. So it's a very very critical piece. But innovation and integration is extremely a critical part of it.
Yeah, and this slide reminds me that the OT doesn't necessarily mean outdated technology. It's meant to be operational technology, but oftentimes that's kind of the joke in a lot of the floors I've been to is that, oh yeah, it's our outdated technology. We can't talk to anything. So
Yeah.
it's good.
You got some great individuals, great technology folks within a plant. They do something which is really cool, incubation type of thing. But is it a sustainable architecture across all the plants as an enterprise, right? So that is where you got to promote innovation at a plant level, but then take that as a starting point and not just confine it to just within the plant or within certain things. And it would be ideal to have all plants the same, but I've never seen one customer where it is.
Right. Yeah, one of these lines is not like the other, right? All right, so now that brings us to our next poll, which is now that we've kind of gone through those areas of interest, we want to see, kind of rank these in order of priority for you. Everybody see the poll?
Again, the surprise, it's not at all surprising. I can see. Yeah, not to say that health and safety is the least important. Definitely, I see different people represent different groups here, and there are different areas of concern. But a good thing to know is they are so intertwined that you have to tackle it holistically. And some of the initiatives you'll be taking it as part of the strategy would also invariably handle one of these two. For instance, if you're really trying to improve the production efficiency by putting a HMI system for the operators, unless you integrate with your ERP system, how are you going to be able to efficiently do this? And if you're trying to tackle, let's say, material shortage, right? Unless you integrate with your inventory system and then give them a front end interface away. So it's not like all or nothing, or you're going to tackle one. You have to have a holistic picture. I mean, it sounds like broken record talking again on the same point, but it's really critical. We look at this holistically.
All right.
Yeah.
Next, we'll move into your man-machine recipes.
Thanks, Frank. It says minds and machines, but rightfully so, because as much as we talked about technology has a role to play here, it is very important to know that it starts with people. So if we go with technology first for your smart factory initiative, I can guarantee we are going to have a lot of surprises. So it's important to take the human centric approach to this whole thing. So when it comes to human centric approach, first thing of first, you have to have a leadership support. You got to have a budget. You got to have a buy-in at the top leadership blessing so that you can take this and roll it as an organizational initiative. It's not a small short journey. It is a journey with some surprises, so you got to have that backing. Now that you got your backing, you got your budget, it is not possible for you to implement this with a limited set of people. It is not a OT problem where you can get 4 or 5 control engineers. Okay, let's get this Rockwell automation in place, or put some Siemens controller PLC, collect some data. It's not a science project, right? So it is important for you to engage all the stakeholders. So by stakeholders, I don't mean only the production managers, the engineers, your quality control, your continuous improvement team, your operational technology folks, your if I said operators, then QC people, IT side of things, the manufacturing head. You got to have a buy-in from all the different stakeholders, to because everybody's concern is different. Because if you come up with a technology based solution, and then last when you go and implement it, you're having an objection from an operator because he has got a practical problem, or a safety engineer. This is a real life example, huh? We come up with a solution, and then we go to the plant and propose a solution, then it gets shot down on one little nuance thing. Oh, I can't run a line here. Yeah, and this is a hazardous thing for people to do. It's a trip hazard, right? And right now I cannot do anything, and it'll take like 6 months for you to even run a line around this. You come up with a great solution. Okay, put a Wi-Fi, blah blah blah. Okay, how is the Wi-Fi going to work in a microwave environment? You may have some disruption. So it is important to take people along when you design solutions. It's not a technology first approach. Take people along, get their buy-in, get their objections ahead of time, work with them to propose a solution. The next thing is the most important thing, right? Like I said, certain things cannot be designed within the air conditioned room. You have to make the effort to walk up and do a plant visit. Like I said, I for one just one customer of ours, I visited 6 plants. No two plants was the same. Not even two plants were same. Every plant had different way of doing things, different strategies, different little nuances, and rightfully so. I mean, when you go and actually sit and understand, it is not because of lack of knowledge. It is because they have a genuine problem which is unique to that plant, why they do certain things the way they do. So unless you empathize, you go sit with them and understand, it is impossible for us to again handle a solution. That's why I think Frank,
Yeah.
you put this on.
Yeah, basically the Japanese have a great term for this as part of the Toyota way. It's Ginshi Genbutsu. It means go and see. That you basically, there's another Japanese truism. It's the frog in the well knows nothing of the grandeur of the sea, and basically you don't know what you don't know unless you actually go and see. And so it's hugely important to go visit and see what's actually going on.
Can't overemphasize that. Yeah. Um, IT/OT, we talked about it. It is extremely important for us to clearly have a strategy as to what data is going to be collected, what help we need from the PLC team, the control engineers, how long the data stays within the plant. It's great to have an IT strategy, but then if you do not have, if you come up with a situation where you're putting some of the IT or a cloud component in the critical path in the manufacturing space, nobody's going to like it, because you may have disruption. You have to have a plan, a failure mode effect analysis done at every level to make sure the manufacturing process does not stop. So it's very critical to know what is the data strategy, what data resides within the plant, how do you ensure that the data that is entered in the plant is accurate, but yet you have one master data across the enterprise so that you have a data accuracy and the data integrity that you're maintaining. Going to the technology side of things, pretty standard. This should be very familiar for you. Starts with the sensors and your connectivity. You pull data, which includes tags. You have to have a strategy of you have to have a strategy where you accommodate and take everybody along. When I say everybody along, the machines of today's world, the machines 10 years old, the machines which are 20 years old, don't be surprised the machines which are 30, 40 years old. So you got to have a strategy that you can't go with, I have all the connectivity in the new age machine. So you have to have a aftermarket a fitment strategy. You have to have a strategy where you cannot upgrade certain things. Backward compatibility, it's important for us to work with that constraint in place. HMI, it's really key to, it's a key component of it, where you can save a lot of little time for the operators and make their life easy. Not just make the life easy, improve the data accuracy. One of our customer actually started saying they had a $200,000 budget they were asked to allocate, not for technology, not for a project, not for a discovery. A $200,000 for buying whiteboards across all their plants so that they can roll out some of their OEE initiative and get accurate data element. So it's important for us to really understand where your HMI will come to a big play, because the time that it takes for a plant manager, a shift manager to walk in to line after line, collect the data, put it in an Excel, then do a data correction, and then send it to the network drive. There's a lot of manual process that goes in. By improving with a good HMI strategy, you are actually improving the data accuracy and you're actually enabling the operator to focus on something that's even more important than entering the data on a whiteboard.
And for those playing TLA bingo at home, what does HMI stand for?
I'm sure most of us know. Human machine interface, it's key. It could be a touch screen based, it could be anything where a human is interacting with a machine, right? There are different ways you can tackle this. If you're weighing the scrap at end of the line, how painless and how frictionless we can make that experience happen. Again, it's so important for us to do the plant visit and talk to the operators and the different stakeholders to know what is the right HMI for that. Otherwise, we'll design something really what you call Web 2.0, 3.0, that may not even make any sense for them, right? It's absolutely, they don't have time and patience for going 5 levels down. It should be simple, precise, to the point. Let them focus on their work.
A classic HMI story I remember is one where we had implemented a new system that was very touch friendly and very clickable, until we went and saw that the main users all used a keyboard. And it was like, oh, there's a fail. So yeah, it's very important to go and see.
Yeah. The next component of this is the data platform. So you have to have a strategy, as we said, because end of the day, all this sensors and your HMI data collection, it's all for ensuring that you have a data which will give you the insights. Your data will speak the truth. So we don't need to speculate. We don't need to come up with hypothesis. The data will tell you the truth, whether one plant is more efficient than the other, then what is that they are doing well, what is that they are doing better, which the other plant can influence. And that's a very common sight. When you get these KPIs and metrics, it really speaks the truth loud and clear. It shows you the mirror. Then you can go back and look at what adjustments you need to do. So having a data platform is key. It's very unique kind of data. Most of the time, you have a time series type of data. You need a database. You need certain compute power which is unique to this type of workload. So you have to have a solid foundation. You can't do a duct tape based solution based on what you already have, but it has to integrate with what you have, because you cannot build something in silo and say, okay, I've got a data platform. But unless it talks to your ERP system, it talks to your rest of the system. It's not going to give you the power and insights what you really need. Last but not the least, the insights which you need to collect plenty of data so that you can derive insights. We are halfway into the presentation. There are some interesting some more facts that we need to jump into. So I'll focus on the solutioning part and some of the things to watch out for.
Okay, I got a future factory next.
Yeah. Comes with different terms. I call it's a symphony of IoT and AI. I say that because IoT does certain things really well. AI does certain things. You have to work in conjunction. They have to work in tandem. If IoT is getting you the equipment health, it is collecting the process data, production data. You have your AI and your ML machine learning and all your analytics, which is going to do a potential failure. Or is this equipment going to likely to failure? What is the prognostics associated with it? Or with this, I'm seeing a pattern. Based on this A, B, C parameters, I'm seeing that this is the most optimal condition in which you are able to operate at the highest production efficiency. So it is critical for IoT and AI to work together. It is not one by itself. Going to the next one, which is the quality side of things, very similar. There are some really, really cool technology. If you take the computer vision based solutions, or you take a laser based solution for looking at your product quality, and then the inaccuracies in the product, or which a visual inspection you may not be able to do, right? It's humanly impossible to do a first pass yield with the highest order with a human or visual inspection. So it is important for you to invest in those technology, the right sensors, but also you got to have a strategy where you can do these insights. There are two things I wanted to mention here. Sometimes you need to go for edge analytics. It is not always cloud first. You can have some of this data flow into the cloud, do some model, but that model goes back to the closed loop, but you do edge analytics right there. Nobody wants this IoT data on the line. When the line is running, you don't want it to go to the cloud, run some algorithm, and then come back. It's too late. Sorry, right? The line is already. So you got to have a strategy for edge analytics, which is where certain thresholds and the parameters or optimal condition under which your product quality is at the best can be decided on the cloud using historical data. But once you have those optimal condition, in order for you to do a feedback loop where you can send this back to your line and then line can adjust itself, that is really critical for us. So you think of the solution as a combination of cloud and edge, or your backend and your edge, and also between IoT and AI. So it's really a symphony and orchestration between both to get to where you need in terms of reducing your cost of poor quality. Moving on to the next one on the stockouts and the material shortage. Again, the it's important for you to have the right mechanism for you to measure the inventory. There are technology solutions which allow you to really do a real-time monitoring of the line speed. How is your material moving, material shortage, forecasting. So you need a combination of both AI and IoT or your sensors, which can get you the right metrics in terms of the shortage supply. Moving on to the next one. So personalized recommendations, AI has its own role by knowing what type of problems are faced based on the persona, based on some of the advanced technology, allowing them to do most complex operation using AI, your virtual reality, AR technology. Doing some simulation is extremely critical, because which otherwise it would put your workforce in a very complex or hazardous environment, but also you're actually training them with the latest and greatest technology. And go to the next one. The equipments, as we said, how do we coexist with the legacy and the modern system? That is really a critical aspect when it comes to the technology and the machinery. So it is always important for us to strive for a single source of truth. It is not uncommon I've heard this many times. We don't have a part master, or we have got three sources of part master, right? Scrap codes. Oh, every plant has their own list of master scrap codes. Quality codes, reason codes. Yeah, we've got our own thing. Oh, this continuous improvement team wants, and which continuous improvement team? Every plant has their own line. So there are it's important for you to have a master data strategy, and then how do you cascade that all the way to the front end. And even in terms of the predictive maintenance and being able to have a just in time notification, so that certain replacements, certain repairs, and certain maintenance can be done, not based on your time based maintenance, based on the condition based maintenance, is really key. So that is where it's really a combination of IoT can tell you some of the metrics, your process control parameters, your production data parameters, but then you need to have your algorithm in place to operate on it so that you can make the right decisions. Last but not least, you might have seen many use cases where there are computer vision technology, there are indoor geofencing, which can keep our workers safe. They are not super complex solutions. Some of them are really simple solutions, which is not futuristic. It might look like a very futuristic solution out there, but they are implementable. They are benefits are real, and you can see it in action. And they don't cost a lot. It really requires a strategy and study so that you can implement for your unique needs, because every plant has unique needs. How you geofence certain areas, what is considered hazardous, and how can you detect certain things right then and there, instead of expecting people to do the right thing, which most of them have the right intent, but different circumstances causes the 20% of fatalities what we see.
All right. Next, we'll go to breaking barriers.
Yes. So I thought I'll share some of the experiences and what I have seen working with some of our customers. So the first thing first, you cannot take a technology solution and proceed with a proof of concept and then keep going and try to evangelize it unless you have a solid business case to solve. There are some cool examples or cool ideas do not take off because of the cost involved in it, and there is not enough justification. Especially some of the technology with respect to the quality control, it really requires you to have some deep pockets, sometimes investment, sometimes a commitment to some of those initiatives, which has to start with certain your diamond or a gold plant, and then show success and then repeat in other plants. You have to establish the cost and ROI. The cost and ROI cannot be done just with one plant in consideration. You have to really to take a holistic look at what does it take to roll out holistically, right? Because some of the challenges are always only seen when you look at the global implementation. For example, what works for one plant will not work for the others. So it is important for us to have at a discovery phase a bill of material. A BOM is required where you take into consideration your cost of your sensors, your MES platform, the technology that goes on the shop floor, your data platform cost, your cloud compute cost. Do you have data scientists in house? Most of them would like to have their own. Sometimes they get the initial work done and then they bring in house, or sometimes they work in tandem with consultants. So it is important for you to holistically look at all the cost components, right? And then justify the ROI, then proceed with your subsequent journey. So that's something you cannot overlook. Coexisting with the legacy infrastructure. So it is impossible to have a green field, though you want to have a green field, but you have to figure out a way, how is my topology going to look in the future world? The plants which are upgraded, how will it look like? The plants which cannot be upgraded, how will it look like? The plants which will upgrade in phases, how will it look like? Excuse me, I have a bad
That's
cold. Apologies. So working with a non-homogeneous environment and having the connectivity is key. Visit plant visit and understanding the constraints is really critical in order for us to have a connectivity strategy. What I mean by connectivity strategy is including the PLC switches. How do you tackle those? How do you get data from that? How, where is the HMI going to get the power from? You may think it's a very trivial thing, but these are the things which brings a surprise. These are the things which will have objections, which will put your journey off and then have roadblocks. So don't overlook any of the little details of your implementation. If you have a blueprint of what your future state is going to be, work with that blueprint and see what are all the challenges and get the buy-in from all the stakeholders. In terms of the data centric approach, like I said, the data integrity is key. Having the single source of truth approach, integrating with the systems of record. Whatever is a system of record for all your individual component, make sure you integrate with them so that your end-to-end data collection, whatever you're having, is accurate. Because your insights is only as good as your input. Garbage in, garbage out. If you have not entered a valid reason code, or if you've not entered a valid part number in whatever, then you're not going to get the insights which are going to give you what you need to do. Other thing is, for us to do any of the AI models, you got to have a critical mass of data. If you operate with a very small set, one line, I'm doing a little science project, it'll stay as a science project. It does not have the potential to become a enterprise solution. So it's critical for us to get the insights with a critical mass. There is no right or wrong number how many plants or lines you roll out with. The dynamics are different, so based on the use case you have to figure out, but it is not without a good critical mass of data, you cannot get some of the insights which will help you to, for example, reducing the scrap. Some of our customers, we are working for the last 3 years, collecting data for the last 2 3 years. Still we are not there yet in some of the goals that they want to accomplish because of the adoption and some of the resistance and the data, the amount of data that is required for you to get to where you need to get to. And the other thing which also we need to look at is, yes, data scientists will tell you the data insights, but it's important for you to take the SMEs along. the subject matter experts, sometimes, I can tell you these are the 10 things that they could be a cause or they could be an effect, right? They could be a symptom or they could be so you really need to have the SMEs along with you, so that all your insights, whatever you're coming up with, the hypothesis that you're coming up with, are validated, and then you can go back and provide that as a feedback to the plant, and do the closed loop thing. Last but not the least, like I said, the organizational changes. It's a very difficult thing. I mean, people have done certain things certain way. We all know it's often overlooked. Whether it's a digital transformation, you're moving to cloud, or from a thick client you're upgrading to, it's a very, very common problem. People are comfortable with what they are doing, because that's what they do. I mean, they nobody likes the change, and especially a fast-paced environment like manufacturing. uh, Doing a change, it might be a cool thing, it might be a faster productivity, but you should be able to convince them. So there is a change management aspect of it which should be baked into your program of IoT journey, where you include that along the way from the beginning. Have a training program, have evangelized this idea, hear the objections, and plan for it.
All right. Well, with that said, we've got another poll here for what obstacles do you see, or what are your biggest hurdles with respect to breaking these barriers? Okay, I'll let you continue to enter those as we move on.
Yep, some of the responses validate what we discussed.
Yeah.
It's extremely important for us to have the sponsorship. Sponsorship is really critical. That's probably at the top of the list, not for you to start anything of the size.
And the money, funding and budget.
Yeah.
Also, yeah.
Moving on to the
Okay,
real case studies. Frank, we can jump into the case studies.
sure.
So we got two case studies we thought we'll present to you today. One is for a leading automotive tier one manufacturer based out of Michigan. 100 plus plants, a global manufacturing customer of ours. They have got presence in North America, Europe, Asia, Pacific, different types of lines, and each line has unique things that they do. Very, very varying capabilities, decade old assembly lines, non homogeneous, heterogeneous environment, $140 million of annual scrap cost. Some of the problems you would be surprised, like putting a wrong label at end of the line, because you're just walking up to the few meters away, shared printer, somebody fires the printer, get the label, put it in here. Mislabeling goes through returns, and the penalties associated with the millions of dollars, you'd be surprised. The data that's entered are, don't be surprised, not validated with any master data. There is no integration with the ERP. Visual inspection in most of the lines at end of the line, right? They've got tons of things to do. Whiteboards, like I said, tons of spreadsheets. OEE is a consolidation of all the spreadsheet into another spreadsheet entered into a web-based application, a data entry system, and then the top floor sees what the shop floor does. So that's not a great strategy. The tag collection, some of the plants had done some, like I said, a little project of sorts with some innovation happening at a plant level, which is a good thing to do, but not standardized, right? What is collected as a tag is not standardized across even two plants. Then how are you going to have a strategy, right? Lack of data strategy. I'm not surprised, you won't, it's a real example. People went to Best Buy, they had budget, bought some hard drive, collecting data. The data stays within the plant. So such architecture design, even the cyber security control was very, very, very decisions were made locally at the plant level. So there isn't a strategy at a enterprise level. So this is the as is state when we walked in, and we were asked to come up with the whole IoT and AI smart factory landscape. So what we did was, if you could go to the next slide, Frank.
Yep.
We started with a design thinking workshop right at our facility. Sorry, I think we lost you. Yeah,
Okay.
design thinking workshop. So that is where you are actually doing some whiteboarding session, bringing in multiple stakeholders from different parts of the world, different parts of North America, get alignment on what is your top problem, right? Is everybody aligned with the problem statement? Which of the problem statement is bothering you the most? What is it you really want to tackle first? How are we going to roll out? What are all the different level of innovations that has happened? Several plant visits were followed after that. I mentioned at least 6 plants I visited to study the technology in place, the process that's in place, how people react, what kind of constraints they have, right? Physical constraints, resource constraints, and whatnot. A standardized view of the master data was established. We worked with the continuous improvement team to come up with a strategy for what is the standardized data, and then who in the enterprise should own the data, right? And then clear the duplicates, do some negotiation with them, come to an alignment, and then focus on an integration projects. So this was spun into different projects. Have a global IIoT reference architecture. It would have been nice that entire all 3 regions would have jumped into the bandwagon and taken this up, but it is ideal world, never it's ideal, right? So you have to have a tactics to it as to which ones are going to embrace us. What is your phase 1, what is your phase 2, what is your phase 3 going to look like, right? So that type of execution or executable architecture is really key. I can give you a fancy presentation. I can give you one of the most complex uh, presentation we have done in terms of the reference architecture, which comprehends all that. But it's of little use if unless you have an executable architecture with your timeline, with your resources, with your budget, your bill of material at a cable and a black box to your license cost. So that is really key. We helped to build a data pipeline on cloud of their choice, and have a strategy where you have one place where you can have exploration for the data scientists. So as we speak with this customer, like I said, we have worked for 3 years. We have done some real cool work with AI based modeling. Some of the visualization will be literally stunning. Can you imagine 200, 300,000 data points, time series data points shown on a web chart? That's something, it's not you cannot get any off the shelf charting component to plot 200, 300,000 points on a web screen to explore. Um, on top of it, we have implemented the ML ops so that any of the AI models which we create can go through your Kafka or whatever pipeline, data pipeline, back to your shop floor so that they have the learnings, latest and greatest data to operate on. So this is a classic case study of journey. It takes patience, it takes perseverance, it takes buy-in from the leadership and sponsorship. But I'm glad to say that now most of the lines are modernized in this. They have visibility to the OEE. Even though some of the machineries have not been upgraded, you have got a different way to collect data. Some cases, a different method to collect data. The wishes at some point of time, those machines can get upgraded once the capital expenses are approved. But like I said, we cannot live in a dream world that everything will be changed overnight, but it has to be a journey as we travel along. The next case study is slightly different from what you saw. This is a case where they already had data collected. This is a packaging firm. They do the packaging tapes, and the real problem was around the bubble pops which happen. When a bubble pop happens, just to put it simple, they have to stop the operation. Somebody has to go up there, tear up the whole thing. It takes around 30-40 minutes for them to restart the line. The 30-40 minutes, the amount of productivity loss, as much as you would see 1.3 pops per line per day. Just multiply and then see the math with it, and then this is a tangible cost with just the pop, but then the indirect costs associated with it, the lost time in manufacturing good parts and so on. So we worked purely on a data engagement with them to get the data which they had already collected from different lines. There were a bunch of data cleanup we had to do because it was not clean. We had a lot of standardization to do, eliminate some junk data. But again, another good example, people say, we have got tons of data, we are already collecting data. Unless you go and say, I will not believe any of those, because yes, you have data, but what is the quality of the data? How much I can really put it to use? So there is a lot of work we had to do to get to a point which is with which we can create models. But I'll be very proud to say that we created models which gave 95% accuracy of predicting the ideal operating conditions where the bubble pop was almost eliminated. So this is a reverse case. It's not predicting your bubble pop. It is more like telling you the process control parameters. They're like 300, 400 little valve pressures and every little thing. So what is the ideal parameters of all those process control under which your bubble pop has been minimal? It would have been a tribal knowledge. It would have taken a trial and error and so much of somebody's head what they do, but it's still not science. So what we did was a data science based project and gave this outcome, and happy customer. Again, very different kind of journey. No IoT involved, pure data play, but it's usually a combination of both which gives you the success.
All right. Well, that concludes the content presentation of the webinar, and next we'll go into the Q&A section. And so for those of you that have questions, you can go and enter them in. If you look on your Teams menu, you should have a Q&A tab up at the top. You can click there, and when you do so, you'll have the ability to ask a question. You can also respond to other people's questions or vote them up, etc. So we'll go into that right now. See if we have any questions.
I'm sorry, I didn't leave a lot of time for questions, I guess. Sorry.
No problem. All right. Well,
yep.
Let a few more minutes to see if we get any more polls or any more questions. Let's see.
Frank, you can leave the contact information or any other information where they can reach out to us after the presentation if they have any questions.
Yes.
Yeah.
Yeah. In fact, let me go. So with that, we have the opportunity to do a complimentary consultation. If you scan this QR code, you'll actually be taken to a Calendly link to meet with one of our sales guys. In this case, we have Jeff has offered to bring those in and watch for the incoming invites. And we ask you to gather any sort of documentation or information that you might have if you want to proactively provide us some information so we can get that going. We're happy to sign NDAs if necessary. If there's anything that you want to share that might be proprietary, we welcome you to engage us. And let's see if we have any questions. We got a nice kudo in the chat. Looks like we are done. So if you want to look at some of the other AI in Action webinars that we've done, you can go to softera.com/webinar. And there you can see we've done some work with copilots in ChatGPT and HR, ChatGPT's impact on finance, accounting, and procurement, supercharging your old systems with ChatGPT, and of course, how to automate your workforce with AI and bots. With that, it's been our pleasure hosting you today, and thank you very much for your participation. And we'll send you a follow-up email and with a call to action and results including this presentation. Thank you so much.